Hi, so in this video we're going to look at first order differential equations, particularly of the form variable separable. Variable separable means that I can separate the variables, obviously. So they look like a standard form of f of a function of y times dy by dx equals g of x, and when it looks like this that means I can separate all of the x's to one side, usually bringing dx up to the right hand side and leaving all of the y's on the left hand side. So our steps are going to be to separate the variables. Then we can integrate both the left-hand side and the right-hand side. I will then attempt to arrange it explicitly in x if possible, and then if we're asked to, we'll find the particular solution. The general solution is when you have a constant of integration left in your final solution, whereas a particular solution is if you're given starting conditions which allow you to find the constant of integration. Okay, so we'll have a few examples. Find the general solution of 3y dy by dx minus 2x squared. The first thing we should notice is that it is not in the standard form. So let's firstly put it into the standard form. Now it is. So let's separate the variables. Let's bring the dx up, and we get 3y dy equals 2x squared dx. I can now integrate both sides, which will give me 3y squared over 2 will equal 2x cubed over 3 plus the constant of integration. And now to arrange explicitly in x, I'm going to multiply through by 2 and divide by 3, which will give us y squared equals 4x cubed over 9. I'm multiplying an arbitrary constant by 2 and then dividing it by 3. It doesn't matter what the arbitrary constant is. We can just leave it as c, as we don't know what that is. It's entirely dependent on what the starting conditions are, so it will be factored in. We only need to change the c if it is multiplied or divided by an algebraic term, which we'll come to at some point, I'm sure. Now, last step is to arrange explicitly in x, which means y equals the square root of 4x cubed over 9 plus c. Okay, so that was a general solution. So we'll do one now which is asking us to find the particular solution. Okay. So again, first thing we need to do when finding the particular solution of 2x dy by dx equals 3y plus 1 is to rearrange it so that all of the x's are on one side and all the y's are on the other side. So if we bring the dx up, we're going to get 2x dy equals 3y plus 1 dx. That's a problem because I need to have the x's on one side and the y's on the other side. So we bring the 3y plus 1 down. Will equal 1 over 2x dx. And now I can integrate this. That's going to give us 1/3 log 3y plus 1 will equal 1/2 of log x. 2x. Sorry, yeah. Nope, because you can take the half out, so it's just log x. Okay. And that's always going to have plus c. Now to arrange it explicitly in x, I can take the 3 up, so I get natural log of 3y plus 1 equals 3 over 2 natural log of x plus, again, can leave the arbitrary constant as it is, natural log of 3y plus 1 equals natural log of x to the power 3 over 2 plus c. Logs on both sides, so get rid of them. So we get 3y plus 1 equals x to the power 3 over 2 plus e to the power c, because I've taken the exponentials to get rid of everything, times e to the power c. That works because we would get natural log of 3y plus 1 minus natural log of x to the power 3 over 2 equals c, giving us natural log of 3y plus 1 over x to the power 3 over 2 equals c. So 3y plus 1 over x to the power 3 over 2 equals e to the power c, and then we bring the x to the power 3 over 2 up. Let e to the power c equal a, because a is an arbitrary constant. E to the power of an arbitrary constant is just going to be an arbitrary constant, so let's call it a. So we get 3y plus 1 equals a x to the 3 over 2. So y will equal ax to the 3 over 2 minus 1 all over 3. And that is the general solution, but I want the particular solution, which is when y equals 2x equals 5. So 2 will equal a 5 to the power 3 over 2 minus 1 all over 3, which is going to give 6 equal to a times 5 to the power 3 over 2, which is the square root of 5 cubed minus 1. Square root of 5 cubed is root 5 times root 5, which is 5, times root 5, which is 5 root 5, so we get 6 equals a times 5 root 5 minus 1. So we get 7 equals 5 root 5a, which is then going to give us a equal to 7 minus 5 root 5. That will then allow us to substitute in for y equal to 7 minus 5 root 5 times x to the power 3 over 2 minus 1 all over 3. And that is our general particular solution to that equation.